Calibration. Really not many changes for your initial calibration compared to stereo PIV. We're still using the same techniques, using a calibration target with either a single plane or multiple planes on the target. The main difference is that we're adding more cameras into the system. Okay? Since all cameras are looking at the same volume, we map all those cameras into the same coordinate system. As far as recommendations, if you're in air or in water, we recommend at least 2 planes. If you have a higher optical distortion through your system, more planes can add more information for your calibration fit. In general, depending on what medium you are looking through, you can use a pinhole model calibration if you are in air and you don't have any significant optical distortions in your way, or that your viewing angle through any windows is fairly small. Okay? If you're looking into a flow field that has a varying index or fraction, like your cameras are outside looking into water or some other liquid, then you must use a polynomial fit. If in doubt, use a polynomial fit, because that takes care of any optical distortions that are between your camera and your flow field. For your initial calibration, Vern later on is going to talk about volume self-calibration, but for the initial calibration there are some best practices just to make your life a little bit easier. The first of which is, of course, if you have access to your flow field, putting that target in the center of your flow field, somewhere near the z equals 0 position. This just gives you a reference point for when you start processing your data. One input that you have to put in is that z depth. And if you have a reference point based on where your target is, that by default becomes your z equals 0 plane. Also, to minimize perturbations that can occur to the system, settling of the lenses, settling of the cameras, your structure, is to calibrate right before or right after you acquire your data. This minimizes the chance that something's going to move during that time. If you do make any perturbations to the system, you tweak the focus of a camera lens, you change the f-stop because one camera is brighter than the other, you should recalibrate. Anytime you touch any part of your system, something's going to move. These lenses that are commonly used aren't very rigid, and if you touch them, those lens elements will move, which will translate into some movement on your pixel array. In some situations, it's impossible to put a calibration target into your flow field. This makes life a little bit more difficult, but there are some tools that you can use. You can calibrate outside your measurement volume, and then start with a very thin light sheet and apply self-calibration, which we normally apply for stereo PIV, to correct for any very gross initial calibration errors. Okay? And this does work. One thing that doesn't work is moving your cameras after you calibrate. That's an absolute no-no unless you have a really, really rigid structure to move everything together.